In these next three videos, we're going to cover nutrition. Nutrition is really important both for health and also for optimal performance. And this is a nice little quote that you might think about, and it's a good one to try to live by. Eat food, not too much, mostly plants. And that should help to keep you healthy if you do that. Well, what is a nutrient? A nutrient, this is a traditional definition. It's changing a little bit, but nutrients are chemicals in foods that are essential for life. But over the past 30 years or so, we've been realizing that there are things in foods, especially plant foods, that aren't essential for life, but they do promote good health. And those include things like antioxidants, phytochemicals, other things. What are the general functions of nutrients? Well, you know, one function of nutrient is that's where you get your energy from. The energy in the food has to be transferred to ATP, and so you know that the majority of biological work is powered by hydrolysis of ATP, and you don't get any energy for biological work from hydrolysis of any of the nutrients. Another important function of nutrients is they make up the structure of your body. And so you know that bone is mostly calcium and phosphorus, muscle is mostly protein, and so on. And then lastly, what they do is they help to regulate metabolism. And again, you know that every chemical reaction in your body has to take place in a watery environment. Enzymes are made up primarily of protein, and hormones are made up of either fat or protein. And so these are the general functions of the nutrients that you need to get. Traditionally, how do we classify nutrients? This goes back, it's traditional. I do want you to understand this and know it. First, we have what are known as macronutrients, and you know macro means large. And so the macronutrients are things that we need in relatively large amounts. And so we measure how much macronutrient we need in grams per day, at least for three of them. And so carbohydrates is one macronutrient. And carbohydrate can be complex or simple, as you know from our chemistry discussion last fall. And so you know that the simple carbohydrates tend to be the mono and the disaccharides, which we'll review in a little bit. And then we have fats or lipids. And fats can be saturated, which you should get in relatively small amounts because saturated fats are bad for you, and then unsaturated. And so the majority of the fat that you get in your diet should be unsaturated. And unsaturated fats can be either monounsaturated or polyunsaturated. And you know that has to do with the existence of carbon double bonds and how many there might be. If there is only one carbon-carbon double bond, then obviously that's a monounsaturated fat. And then we have proteins, and you know that the building blocks of proteins are amino acids, and there are two types of amino acids, at least nutritionally, the essential amino acids and then the non-essential amino acids. If you want to know the essential amino acids, then memorize the mnemonic Private Tim Hill, and that will help you to get those, but we're not going to go over that now. Water traditionally has not been included as a macronutrient, and probably because you don't get energy from water, but you do need water in large amounts, and so it is a macronutrient. We don't measure the amount of water you need in grams per day. We usually do it in ounces or milliliters or something like that. And then we have what are known as the micronutrients, and that's because they're only needed in milligrams and in some cases micrograms per day. So very, very small amounts of these nutrients are required each day. We have the vitamins, which can be broken down into those which will indeed dissolve in fat. And I hope you remember from our discussion of digestion that those are picked up by the micelles, and that's how they're delivered in between those microvilli so that they can move across the membrane and get into the enterocyte. And then we have water-soluble vitamins, and those are the ones that will dissolve in water, and so they're polar, like water is polar. And then we have minerals, and minerals were traditionally classified as macro, not because we need them in grams per day, but because we need them in milligrams per day versus trace, which we only need in micrograms per day. So very small amounts of some of these minerals are required. Okay, and so which of these nutrients provide energy? Well, only the first three macronutrients, carbohydrates, fats, and proteins, can be broken down to get the energy to put into the high energy bond of ATP, phosphocreatine, and other compounds that have high energy bonds. This is a newer classification of nutrients, and so I want you to look at it and think about it. Water, again, is obviously a nutrient, and some people would say it's the most important of the nutrients because without water you can die within a couple of days. And then rather than saying protein, they're saying the amino acids. So you need these 9 essential amino acids, and these include what are known as the branched chain amino acids, which those of you who are very interested in building muscle may know about. There's absolutely no evidence that extra branched chain amino acids help you build muscle to a greater extent. Then again, we do have the vitamins. The fat-soluble vitamins are the A, D, E, and K. And so they're found associated with fat. And again, they're absorbed along with monoglycerides, fatty acids, cholesterol, and other fats using that micelle. And then we have the water soluble, including C. Vitamin C is water soluble. And then all of the B complex. These are water soluble as well. Generally speaking, when you get excess B complex or C vitamins, you just lose them in your urine. The B complex include thiamine, riboflavin, niacin. B6, which still keeps its number, but is also known as pyridoxine, pantothenic acid, folic acid, and this is sometimes referred to as pantothenate, and this is sometimes referred to as folate, and then biotin, and finally B12. And then energy sources. And so now rather than including carbohydrate, they just say energy sources. I've read some interesting studies recently that suggest that carbohydrate is perhaps not as important as we've told people it is for the past 100 years or more. And then fatty acids. The only fatty acids that are essential for you are linoleic, which is an omega or N6, and alpha-linolenic, which is an omega-3 or N3 fatty acid. And again, just quick review, I hope you remember that omega-3 means that the first carbon-carbon double bond is 3 carbons in. This is the omega carbon. We go 1, 2, 3, and there's that carbon-carbon double bond. And so this is alpha-linolenic acid, and it is one of the essential. Linoleic acid, on the other hand, won't have its carbon-carbon double bond located here to begin with. We're going to go 1, 2, 3, 4, 5, 6. And so that's where you'd find the first carbon-carbon double bond in linoleic acid. And again, these are the two that are essential. You get these in your diet, you don't need any others. And notice that these are both polyunsaturated. The truth is you do not need any saturated fat in your diet at all. And then again, the minerals, we break them down. And so now we say minerals are the things that we need in larger amounts. Calcium and phosphorus to build bone. Magnesium is also part of bone. And then iron for hemoglobin. Remember, you've got trillions of red blood cells. Each red blood cell has millions of molecules of hemoglobin, and the hemoglobin has 4 iron elements in each one to make it up. And then we have the trace minerals, zinc, copper. This is manganese. There's iodine. And so I hope you remember iodine from talking about the thyroid and how the thyroid gland works. I'm not going to make you learn what some of the functions of these are. Sodium, potassium, and chloride we've been talking about a lot, going all the way back to last fall semester. Important for action potentials in neurons, in skeletal muscle, in cardiac muscle, in the cardiac conduction system. Also important in fluid balance and fluid regulation. And so we've talked about sodium, potassium, and chloride a lot, and they now are classified as the electrolytes, and you know that you can get drinks, which are supposed to help with rehydration from exercise, that contain all the electrolytes. And then finally, we have what are known as ultra trace minerals. Surprisingly, AS is arsenic. Most of you know of arsenic as a poison, but the truth is that we find arsenic in every single cell in the body that we look at. Still trying to figure out why the heck that is, and if it has a function, what is that function? And so that's a newer way of looking at nutrients. For the rest of this video, we're going to go ahead and look at carbohydrates. And again, much of this will be review. And then in the next couple of videos, we'll go ahead and we'll look at lipids and proteins. Well, a carbohydrate, you know that a carbohydrate is a compound made up of carbon, hydrogen, and oxygen arranged as single units of sugars, monosaccharides, or multiples of monosaccharides. And so monosaccharide is the building block, and we can build those into polymers. Well, you also know that the primary role of carbohydrate is to provide energy. And each gram of carbohydrate gives you about 4 kcals of energy. And so if you had something that had 10 grams of carbohydrate, it'd have 40 kilocalories of energy in it. The brain needs carbohydrate. Well, that's what we've been told for a very long time. We're starting to look more and more at what are known as ketogenic diets, and we're beginning to think that maybe carbohydrate isn't as important for brain function as we've always told you that it is. It's important because that's what your body has adapted to rely on. But if you start to go on to a ketogenic diet, your body takes a few days to shift, but it starts to shift so that the brain can use keto acids in place of the carbohydrates. So maybe carbohydrate isn't quite as important as we thought. It is true that fat burns in the flame of carbohydrate. And so remember, oxaloacetate, OAA, is one of the starting compounds of the Krebs cycle, and it will combine with acetyl-CoA at the very start. Well, the oxaloacetate is made from carbohydrate, and so you do need some carbohydrate to provide that OAA, but maybe not as much carbohydrate as we've been saying. And so we need to start to study ketogenic diets more closely and look at them in terms of both health and performance. There's also some data that adequate carbohydrate intake preserves tissue protein. And so we know that bodybuilders think they need lots and lots and lots of protein, and they think that it should be animal protein. We'll talk about protein later on and see that that too is not necessarily true. And then you also need a bit of carbohydrate to make your nucleotides, because a part of the nucleotides is either ribose or deoxyribose. And again, OSE, sugar, OSE, sugar. And then we also make glycoproteins, which are very important parts of cell membranes and are used in other parts of the body. And so those are some of the roles of carbohydrate. And I guess what I should have said real quickly is, here you can see examples of some good healthy carbohydrates. Lots of good carbohydrate in fruits and vegetables, seeds and beans, and then also nuts and even whole grains. And gluten gets a bad rap, and it shouldn't get a bad rap. And then here are some really bad sources of carbohydrate because highly processed. White flour and sugar and even saturated fat in these guys. And so bad carbohydrate, bad, bad. All right, and now we move on. Monosaccharide, one sugar. That's what it is. And here you can see the ultimate monosaccharide. This is glucose. And you can see that it does form this ring structure with 5 of the carbons as part of the ring, and then number 6 is up here. And you know that the formula for this is C6H12O6. If you want, you can pause the video and count that to remind yourself of that. A single unit of carbohydrate has that general formula that we've talked about before, CH2O sub N. And look at there, water, H2O. And so carbohydrate is a hydrated carbon chain. And then we just go ahead and stick in N. And so in this case, N is going to be 6. 6 carbons and then 6 H2Os. Well, what are the common monosaccharides? And again, you know, glucose, fructose, and maybe you remember galactose, but maybe you don't. But glucose, again, is the primary one. Here you can see glucose, again, in the ring structure, also just a straight line formula. Here you can see fructose, and now you can see we've changed the shape of the ring structure, and now 2 of the carbons are located outside of this, but we've got 1, 2, 3, 4 of the 6 carbons do help to make up the ring structure. And here you can see differences in where the OHs and the COO are located. And then finally, here's galactose. And you can see that glucose and galactose are very, very, very similar. And it's your body tends to change both fructose and galactose into glucose. And so it's easy for the body to do that. If we combine two monosaccharides, well, get rid of mono and replace that with what? We get a disaccharide. And so now we've got two units put together. What are the common disaccharides? Well, you know, that maltose. And we talked about maltose in digestion. So when your body breaks down starches, it tries to get many of them down to maltose, which is two glucose molecules linked together. Lactose is milk sugar, and so lactose is a glucose and a galactose together. And this is actually where most people get their galactose from. You don't need galactose. I don't know the last time I actually had a milk product. Well, actually, I do eat cheese some. And then finally, sucrose, which is the table sugar. And again, I'm going to point out to you, OSE, 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 carbohydrate or sugar. And so saccharide and ose tell you that what we're looking at is some type of carbohydrate. That's what we're looking at. Okay, and down here you can see sucrose, commonly known as table sugar, and so it's a glucose and a fructose linked together. And so it's 50% glucose and 50% fructose, which is what high fructose corn syrup is as well. They convert corn into high fructose corn syrup because it's easy to store it and it's easy to deliver it, and so they make more money off of it, and they don't give a shit that it's not good for you. There has been recently a backlash against high fructose corn syrup, and now I go into the stores and I see things like a can of soda that says contains only natural sugar. Well, I'm sorry. What they mean it contains is this stuff right here. This is not natural sugar, and it's just as bad for you as the high fructose corn syrup, and they are indeed both bad for you. And it would be great if you didn't get any of this in your diet, but I understand that's incredibly hard to do. So the plan is try to cut out some if you can. Now we can combine more than two monosaccharides and we can get what are called oligosaccharides. That would be 3 to 10 monosaccharide units. And the two most common are stachyose and raffinose. And these are things that you find in beans. And so navy beans, pinto beans, lima beans, on and on and on and on. And beans are really, really healthy for us. And they're something that we should try to get more of in our diet, because not only do we get these good carbohydrates, we get a good source of protein, and we get very little fat. And so the stuff that you see down here is incredibly healthy for you, incredibly healthy. And then if we put together more than 10 of these monosaccharides, we get polysaccharides. And the common polysaccharides, you should know these guys. We've talked about them multiple times now. And so starch, and we talked about starch when we did digestion. That is the plant storage form of glucose. And then glycogen, and that is the animal storage form of glucose. And fiber is a non-starch polysaccharide that we find in parts of plants, including leaves and stems, the skin of things like apples and other things. And important fibers that we know are cellulose and hemicellulose, and then there are lots of others. And as we said when we talked about this during digestion, you don't have enzymes that your body makes that can break these down, but they do get broken down a little bit by the bacteria, the good bacteria that you have in your large intestine. And this is good for us. One of the byproducts is those short-chain fatty acids that we'll talk a little bit more about in the next video. And these are used as an energy source by the colonocytes. And the bacteria in your gut breaking down fiber helps to protect you from colon cancer. And so again, many people in developed countries should try to increase the amount of fiber that they get in their diet, and not by eating Fiber One bars. Those are just glorified candy bars. That's all that is. Here you can see glycogen. And so again, this is the animal storage form of glucose. Here you can see those individual glucose molecules, and it's highly branched. Now, you don't get much glycogen at all in your diet because you know that glycogen is stored in muscle, and you know that a steak or a pork chop or something like that is muscle. But when you kill the animal, and you do have to kill the animal before you can eat the pork chop or the steak or the hamburger, that glycogen is degraded very quickly. And it gets even further degraded when you cook that thing. So there you go. Well, here you can see amylose, and we did talk about amylose when we did digestion, and you can see that it is a whole bunch of glucose molecules linked together, and you notice that amylose is unbranched. They show it to you in this chain that forms a helix, but it's still unbranched. And then the other common form of starch is amylopectin. Again, it's just stored glucose, but now you can see it's highly branched, and so it's branched a bit more like glycogen. But these are the two major forms of starch that we get in our diet, amylose and amylopectin. And again, you see OSE. And these are broken down by amylase, starting with salivary amylase in the mouth and finishing up with pancreatic amylase in the small intestine. And that gets us down to maltodextrose and maltose, which are trisaccharides and disaccharides. And then they get further digested by those enzymes that are found in the brush border, right in the phospholipid bilayer. And then finally, here you can see cellulose. And so this is a form of fiber. Oh, look at that. It is made up of glucose molecules, but the problem is that our enzymes can't attack these bonds because they're not the same as the bonds that we find over here. And we're not going to get into that. We're not going to worry about it. But cellulose is still good for you. You should get cellulose in your diet, and it helps, as we'll talk about more later. The mono and disaccharides are also known as sugars or simple sugars. And these things are pretty much just empty calories. The oligo and polysaccharides are known as complex carbohydrate, and far and away the majority of the carbohydrate that you get in your diet should be these complex carbohydrates. There is absolutely no need for you to get simple sugars in your diet. No need. Zero. But you will get you'll get fructose, fruit sugar, if you eat fruits and vegetables. Back in 1915, a little more than 100 years ago, the average sugar consumption was about 17.5 pounds per year. To me, that sounds like a lot. I hope I don't eat 17.5 pounds of sugar each year. I suppose I might. The estimates today range from 57 pounds per year to as much as 100, and that would be the average. And so that means that there are people who are consuming in excess of 100 pounds of sugar a year. Holy crap. The American Heart Association recommends no more than just over 30 pounds per year. What the hell, really? If we only needed 17.5 pounds per year in 1915, and again, the truth is we didn't need it, why are they saying 30 pounds per year? And the reason is because we get so much right now that cutting back to zero, most people would say, oh, I just can't do that. I'm not even going to bother to try. And so they're trying to set some limit where they think people at least will try to make the attempt to cut back on the sugar that they're getting. How much sugar is needed in your diet? You don't need any sugar at all. None. Zero is what's needed. Well, here is some very interesting data from back early 2000s, and the number of subjects tested was nice and high, and this is the amount of sugar getting per day for these people, these kids. Look, they're all kids. And so their body mass is relatively low, and I've converted that into, well, how many calories per year is that? And so you can see that the number of extra calories per year is staggering, and then we convert that into potentially pounds of fat to put on per year. And you can see that those kids were putting on 40 to 50 pounds of fat per year and more. And here you can see this kid getting this giant cup of liquid candy. This is well over 12 ounces. And so these two are getting a great start on type 2 diabetes, non-alcoholic fatty liver disease, and other chronic diseases. And so we need to try to educate parents about the negative effects of a diet of McDonald's and things like that. Well, why is sugar intake a concern? This is a great book. You might want to go look this up and read it. This came out back in I believe, the late 60s, maybe the early 70s. I'm not positive. But the title of the book was Pure, White, and Deadly. It was written by this physician from England. The sugar industry basically destroyed this guy. They really kind of attacked him and ran him down and said that he was a bad scientist. But high sugar intake is linked to lots of bad stuff. Chronic inflammation. And most of the chronic diseases that affect us today are inflammatory diseases, including type 2 diabetes. And you know, there are millions of people who have type 2 diabetes, and even more who are pre-diabetic. Coronary artery disease. Again, remember that the sugar causes ulcerization of the endothelium, and that's how we get it started. Also contributes to early wrinkling of the skin. And so those of you who would like to have leathery skin when you get to be my age, eat a lot of sugar and lay in the sun a whole lot, and maybe even take up smoking. Okay, sugar also causes increases in blood triglycerides, which are not good for your cardiovascular system. It contributes to earlier cognitive decline. NAFLD, as I've said a few different times, NAFLD is non-alcoholic fatty liver disease. Obesity, despite what Coca-Cola and Pepsi will tell you, sugary drinks do help to contribute to obesity in kids and adults. And then we've known for decades and decades that it can cause dental caries or cavities and gum disease. So this is some bad stuff for us. And then, as I told you earlier, these things are just empty calories. Nothing here but calories. No vitamins, no minerals, no fat, no protein, empty calories. When you get sugar from a carrot, you're also getting a lot of other stuff in there, lots of vitamin A and other things. And when you're getting sugar from apples, you're also getting vitamins and minerals and even a little bit of healthy fat in there. And so, yeah, sugar, not good for you, but when you get it in fruits and vegetables, it's okay. This is an interesting, I took this picture for you. I measured out just under 10 teaspoons of sugar because that's what you tend to find in a 12-ounce can of Coke. 9.7 teaspoons of sugar turns out to be 39 grams, and so 156 calories in a 12-ounce can of Coke. Well, in today's day and age, most people don't stop at 12 ounces. They go well beyond that. Well, what if we go to orange juice then? How about orange juice? There's a good healthy drink for you, right? Well, holy crap, look at that. 23 grams of sugar in a serving, and we got to look here. A serving is only 8 fluid ounces. So let's convert that to 12 ounces. And when we do that, 2.88 grams per ounce times 12 ounces, 34.5. Holy shit, that's only slightly better than a glass of liquid candy. And so sugary juices aren't good for us either. We think that we're doing ourselves a favor, something nice and nutritious, but no, we aren't. I looked up some other things that people might like to have every once in a while. Some people more than every once in a while. A caramelized honey latte, 45 grams. A classic chocolate frosty, 46 grams. You can get that down under 30 if you just do a junior frosty. Molten macaroons. I guess these are candy. No, I'm sorry. These are cookies that you can get from Trader Joe's. 43 grams for one cookie. Who can eat one cookie and stop there? And then Tazo iced green tea is 30 grams, but they make this in other flavors which are higher than the 30 grams. And here's something that you should keep in mind. For whatever reason, and we don't entirely know why, your hypothalamus doesn't register calories in drinks. It doesn't do it. And maybe that's because we evolved drinking only water, which has no calories in it. I don't know. That's just pure speculation on my part. But when you drink these things, they just get added right on top of the calories that you get in the foods that you eat. Most nutritionists today's day and age just recommend that you try to have water with your meals, 0 calories, because again, we don't register these things and they get added on and they become extra calories through the course of a day. Well, a second reason that sugar is bad for us is because it's replacing fiber intake. And here again are good sources of fiber for you. Pink grapefruit is one of those superfoods, really good for you. These are plums, and then here are some whole grains, which again are really good for the vast majority of us. Only a few of us have problems with the gluten that we find in grains, and these are good for us. Low fiber intake also linked to obesity, type 2 diabetes, coronary artery disease, and then even intestinal disorders like diverticular disease. We get these little pouches in the large intestine that can then become inflamed, and so then maybe you have to go in and have them cut out part of your large intestine. And then, of course, constipation. Everybody loves a good case of constipation. Who doesn't enjoy sitting on the stool, straining and groaning to try to drop a deuce? And then cancer, although there are some newer data that question the link between cancer and fiber intake. I don't know, I guess we need to research that a bit more before we'll really know. What are some of the benefits of fiber? It can help to decrease serum total and LDL cholesterol. LDL cholesterol is that bad cholesterol, contributes to heart disease and other cardiovascular diseases. The fiber can help to decrease blood glucose levels so you don't get as big an insulin response. Helps to prevent constipation and diverticular disease. It actually slows the rate of digestion and absorption of some carbohydrate and fats. That's good. That means you don't absorb quite as many total kcals. It's a small amount, but if you eat fiber all the time, it can add up over decades and decades. There's also an inverse relationship between fiber intake and blood pressure. And again, we know that hypertension is also something that many people in the developed countries will suffer from. How much carbohydrate do you need to get each day? Well, people have said roughly 60% of calories. The macronutrient distribution range is anywhere from about 45 to 65. And so you could cut way back on that and you'd be fine. Added sugar recommendation is less than 10% of calories. Currently, people are getting more than that, but remember, you don't need any. You don't need any. I've had a few students in the past. I don't know how many of you know Jordan Dolph from Marino Dolph. Their older brother, Robbie, graduated, I guess, 2 years ago now. He just didn't eat anything with the sugar in it, and I always thought that's fantastic. I wish I could do that. That's good. A better way to think of it is how much do you need based on your body weight? And you need about 4.5 grams per kg of body weight, unless you're highly active. And so then for people who do lots and lots of running like Jenny and other people who should be exercising a lot now, we recommend you bump it up to 8 to 10 grams per kg of body weight for those people. McDonald, back in '99, he estimated that you need 200 grams per day to sustain brain metabolism and muscle function. Again, I'm going to say maybe not so much. Maybe this is because we've adapted to relying on high carbohydrate diets. And I'm going to look more and more into low carbohydrate diets and ketogenic diets to see what the effect of those are, both on health and also on performance. Fiber intake, well, current is about 12 to 14 grams. National Cancer Institute recommends that we get that up over 20 to 30 grams per day. And so here are some things that are whole grains. Whole wheat, oatmeal, brown rice, bulgur. I don't know what's made out of bulgur. I don't eat bulgur much, I guess. I don't know. Buckwheat, popcorn. I love popcorn. Unfortunately, I like it with lots and lots of butter, and so that doesn't help me much, does it? And then barley. And then here are some things that are refined grains. The more refined, the worse it is for you. And so white rice, white flour. Did you know that white flour is actually bleached? And it takes out the vast majority of the nutrients that are in there. When we start with wheat, lots and lots of nutrients, including some protein and some healthy fat and lots of vitamins and minerals. Well, white flour, no, we got rid of all of that stuff. And then cornmeal and most pasta is made with white flour, but they are, you see lots of stuff on the shelf these days, which isn't. And then other things as well. And so stick with this column over here. And this column, not so good. I'm just going to talk real quickly about the glycemic index of a carbohydrate. This tells us how quickly and how high does blood glucose go up when you eat 100 grams of a carbohydrate. Kind of like what we did in lab when we had people take those glucose tablets. And so you can see that something which is a high glycemic index food, blood glucose goes up quickly and it goes up nice and high, but then boom, it goes crashing down again. Again, much like happened in the lab that we did. Okay, and here's a low glycemic index food, and now you can see that the blood glucose goes up much more slowly, and it doesn't go down nearly as quickly, nor does it go lower than it was before. And I think that I'm going to modify that lab so that some of the people, instead of just getting those glucose tabs, are going to get grapes, and some of them are going to get oatmeal. And so we'll see what happens. And so again, this is a measure of the extent to which blood glucose rises after you eat 50 grams of this stuff. And this is just a different depiction of a food that's high glycemic index versus low glycemic index. They've been doing a lot of looking at glycemic index to talk about whether or not it's related to health or to exercise performance. Some people are saying that prior to exercise, eat foods with a low glycemic index so you don't have this sugar crash afterwards. And then post-exercise, eat foods that have a high glycemic index so that you replace your muscle glycogen quickly. And so, yeah, maybe yes, maybe no. Part of the problem with the whole glycemic index thing is, number one, it depends on how is the food prepared? Did you eat it raw? Did you cook it? Well, how did you cook it? Did you roast it in the oven? Did you boil it? Did you deep fry it? All of those things have an impact on the glycemic index. And then when you mix it with other foods, that also changes the glycemic index. So glycemic index of a food is not the same as a glycemic index of a meal. And so we've got problems with glycemic index, and we don't know how important it really truly is. Another thing that's been come up with, which is somewhat related to glycemic index, is glycemic load. And now this is an index of how much sugar is in a food as opposed to the effect it has on your blood glucose level. It also looks at the effect of carbohydrate food has on blood glucose, but it includes the portion size. And so the glycemic load is GI, glycemic index, times the grams of non-fiber carbohydrate in the serving, and then you divide it by 100. And so that's what you do. And so GI is based on 50 grams. A typical serving may contain much more than or much less than 50 grams. And so now we look at the glycemic load of the thing. And so here you can see glycemic load of carrots versus the index. Oh, look at that. Glycemic index is 49, but the load is only 2. So there's not that much total glucose in those carrots. Here you can see potatoes way, way higher glycemic load than the carrots. And the index is also higher. Here you can see popcorn, look at that. And so again, popcorn is much like carrots, the glycemic index about 49, but the load is very low. And so this is, again, a good snack because it's whole grain, but you're not getting that much total carbohydrate out of it. Here's a bagel. And so there you can see some data on glycemic index and glycemic load. In the next video, we'll look at fats, and in the one after that, we'll look at protein. And that brings us to the end of this guide.